This morning we're going to discuss just kind of the basics of, or not really the basics, but we're going to use an example of using the quadratic equation in a stored procedure and getting the result, and kind of just showing what the capabilities of as far as SQL Server and pretty complex algorithms. And I use a quadratic equation because some people can think that it's a fairly complicated equation, even though what happens with programming in general, whether it's C#, whether it's Java, whether it's TSQL, you name it, it simplifies any mathematical operation. In fact, those become really easy to do. Whereas sometimes your equations that may involve words or strings might be a little bit more complicated. So we're going to just kind of show you that we can actually do this fairly simply as far as building a stored procedure which will return the quadratic equation and even check the answers. So I'm not going to go ahead and type it all out because it would take a while, and the code is on GitHub, so if you want to play around with it you can. But you can see that we have the procedure quadratic algorithm, and what I've done here is I've shown the work as well as put the answers. So the answers to the quadratic equation are right here, the x plus and x minus. And you'll see that there's also steps. So step one takes it, step by step. So for those of you who are unfamiliar, the quadratic equation comes from this formula right here, ax squared plus bx plus c equals 0. And so, the a, I believe the quadratic equation is minus b plus or minus the square root of b squared minus 4ac divided by 2a. So the a's and the b's and the c's basically come from this formula. And in fact, you can Google it and get to Wikipedia, and it'll show you the quadratic equation. But it's, like I said, it's the minus, and you'll notice too that's minus b plus or minus the square root of, and so that's where you have the x plus and the x minus. That's going to be a different answer. Yeah, it's usually a different answer. I can't think of. It's been a long time since I've done the quadratic equation, so off the top of my head I can't think of a time in which I got the same answer. But one of the things that I remember about the quadratic equation was we had to plug back in the answer to check if it was the plug back in the solution to see if it was actually the answer. And the reason is because sometimes you'll plug back in one of the answers you got in the equation, that equation ax squared plus bx plus c equals 0, and it doesn't equal 0, which means it's not a solution. And I remember that because I got one of my problems wrong in high school, and they were like, oh, you didn't check your answers. And I was like, oh, okay. So we go through all these steps, and you can see this is the final answer right here. And so we break the steps down. Now you'll notice a couple of things, and the key here, the key takeaway here is the TSQL, not really the quadratic equation, because there are plenty of places you can get the answer anyway online. But you'll notice that we're breaking down each step here, but we're also putting this all together. Order of operations does become very important. For instance, we're doing this very early before we're throwing, the b minus 1. We're multiplying to get the minus b value, b times minus 1, before we do the square root, and the square is inside of the square root, and the square root is wrapped around the square b minus 4ac. Right, we're doing that first, and then next, and then next, and then next. That's very important because I've seen algorithms where they were not doing it in the right order, and they're like, hey, I don't know why I'm getting the wrong answer. In programming, it's important to do order of operations. So one of the things you can't forget in math class is order of operations. Even if you don't remember really how to add or subtract very well, as long as you can figure out what's the right symbol to get the right answer, that's great. But if you don't do your order of operations right, you're going to get some really weird numbers. Okay, and then of course I show the steps. So step 1, step 2, step 3, step 4, step 5, 6, 7, 8, so on and so forth. Those are just kind of each of the individual steps, and part of that is I could theoretically check the answer. So as a case in point, let's do okay, and I'm going to do it this way, just so that I can control things a little bit better. And then of course, and I'll get into this in a second, I have some variables here. going to be using some negative numbers. Okay. Is that what it's called? Quadratic? Oh, algorithm. Okay. Whoops. Okay, let's scroll up here. Okay, so here's what it looks like in terms of step 1, step 2, step 3, step 4, step 5, step 6 plus, step 6 minus. So now we've gotten, everything is straightforward until we get to the plus and minus part. And then of course we have basically the final answer. Now again, in the quadratic formula, and this is the reason why I kind of use this one, is not all answers are the correct, or not all solutions are the correct answer. So you have to plug it back in the equation, and going back again to the ax squared plus bx plus c equals 0, whatever your x value was, whether your x value is this or your x value is this, plug it back in, and it has to equal 0. So you'll see the check plus and the check minus. So it's checking these answers, and if they're 0, they're good, and then it'll print out x plus is a solution and x minus is a solution. Okay, so let's go into that, because this is the other thing too as well. Again, with TSQL or any programming, if we have an algorithm, but there's a possibility that the algorithm may not actually produce the right answer. Having a tool like this is good, because then we can check the answer before producing it. So in this case, and you'll notice how there's a lot of different tools that we're using now that we've discussed in previous videos. For instance, now we're using Dynamic SQL. You'll notice that, for instance, A, x plus, B, and C are all being put in to this algorithm. They're all being casted and put into this algorithm because they are not local to this Dynamic SQL. So this is kind of a good example of how to use Dynamic SQL as well, because I can't just throw in A within here. So for instance, if I say, select A as a case in point, it's not going to do anything because A doesn't exist in that scope. This is a completely different scope. So I have to put in A, B, C, and X plus as varchars. I have to cast them and put them in this varchar string. Otherwise, you'll get the error message. I can't think of the error message right off the top of my head, but there's an error message that basically it cannot convert an int to, or I'm sorry, a decimal to a varchar, or vice versa. And that's because you have to cast these numerical values as varchars and put them in. So then it selects, and this is where we're seeing this in this query, it's going to select these two values, and then we have another if statement, and this is if check equals 1, if check 1, equals 0, and if check 2 equals 0, then we'll print them as solutions. If they don't, then they don't get printed. And I'll illustrate this example with something different. Let's see, I'm going to use 7 here, and I'm going to use 0 here. And then V1. And the V1 and V2 are basically the signs between, again, you have ax squared plus bx plus c. So you have the plus between the ax squared plus bx. That sign can either be a minus or a plus. And then you have the other one, which is between the bx and the c. It can be a plus or a minus. So in this case, we're going to look at where a equals 1, b equals 7, c equals 0. So basically this equation would be x squared minus 7x. And our solution is 0 and 7. Now if you, or negative 7, that's very important. This is where you get tripped up at. If you think about x squared minus 7, and 1 second, x squared minus 7x equals 0, that being the algorithm, because there is no c here. There's c's left out, so c becomes 0 by default. So if you think about that equation right off the bat, if our answer was 0, x squared, if x equals 0, 0, minus 7x, x is 0, 0, 0 does equal 0. But if we think about negative 7 as a case in point, negative 7 squared is 49. Minus 7 minus x, 7 times, I'm sorry, negative x is negative 49, but the minus the negative 49 now becomes plus 49, so our answer is 98. So what it should print out is that only x plus is a solution, and you see that's exactly what it does print out. It doesn't print out the other one. So, and I haven't checked this on like every single algorithm out there, so there may be a few that it breaks on, but this should be kind of an example of how to use, like, for instance, a quadratic equation, and then how to check your answer. Now, the main takeaway here is you can see no joins again. This is an actual just kind of mathematical algorithm. But let's suppose you're an engineer and you're using derivatives and integrals and those type of things for your solutions. You can put this in to code. You can then check your answer to make sure that it's correct, and then you can continue in your algorithm. So, and you'll see there's all these tools because yes, I mean, again, in checking an answer, it may not exist in the same scope at all. And I'm trying to think 1 second. And the main reason why I had to do it this way, the dynamic SQL, if you're wondering, well, why would you do dynamic SQL that way? Well, we have signs, right? And these signs can affect the equation, whether it's a minus or a plus. You can't just throw a negative number at the problem or flip signs on the numbers. It's going to use the actual answers here, and you can't go flip signs around over here. So that's the reason why you have to use dynamic SQL. How else are you going to allow the user to pass what signs there are in that? And so that's the other thing too as well. Again, if you're, let's say, an engineer and you're using a very, very complicated algorithm, once again, you can use something like dynamic SQL to go ahead and throw in and let the computer decide on the signs. In fact, you could actually create, programs where you could determine what signs get passed in to the program as well as what numbers, and then it would do all the calculations for you. And you can, again, find a lot of these online, but this is kind of what's going on behind the scenes, at least in TSQL. Again, C# and Java, all those can do almost the exact same things. But we can develop algorithms that are very complicated in TSQL and run these numbers. This is, for instance, a stored procedure. Just as an example, you could do this as a function, and you could pass in that function 3 different columns, which is the A, the B, and the C, and then it would produce the answer, or the answers, and then check the answers on other columns as well, and that would be your product. And so, in fact, as a case in point, just to give you an example of an algorithm that we use a lot, not the quadratic equation whatsoever, but that we use a function a lot, is to go in and get a count of all the columns, I'm sorry, not all the columns, a count of all the commas in a string. So we have, let's say, a table of, 1 million strings, whether that's like users typing something, messages to their friends or whatnot. And so we go in there and we get all the commas in the strings. And it sounds crazy, but just as a case in point, the number of commas that a person uses in a string is correlated with certain financial behavior. As crazy as it sounds, but people who use more commas in their strings are more likely to engage in financially, just as a case in point, financially responsible behavior, whereas people who don't are not. Another example of that is people who with text messages, let's say you have a bunch of text message data, people who capitalize their text are more likely to be financially responsible than people who do not capitalize their text. And so, again, the function that we apply to a string column, for instance, is to count the capital letters or to count the commas in a string, and that produces that result. And again, it's much simpler, actually, than this. This is actually it looks like a fairly complicated algorithm, I guess, to others, but what it really is just a quadratic equation. But again, the count is you're going to break it up by each individual comma. It's going to go through and count each individual comma, count it, and then it performs a check, and then after it performs that check, we see the result and we say, okay, this is correlated with so on and so on behavior. So anyway, the point is, like, these are ways, this is just an example, and this is a mathematical one only, and so it works beautifully in the sense that it's very logical. Strings become a little more relative how you're going to do things, but when it comes to math, it's very logical, straightforward. So anytime you have this really complicated mathematical algorithm that you have to use, and you're thinking, I don't know how I'm going to do that, I have to do that only on the front end, you actually can do it on the back end as well.